Okay, before we start graphing exponential functions, let's kind of talk about these and review some of these concepts. And we better look at the laws of exponents that we've studied in the past and kind of review what those are all about. So here's a couple that are kind of important. If we've got a product a times b to the x power, that's the same thing as a to the x times b to the x. Should be a little dot there, I guess. And if we have a quotient a over b to the x, that's the same thing as a to the x over b to the x. And this is kind of an important one. If we have a to the negative x, that's the same thing as 1 over a to the positive x. And here's some examples. If I have 3 times a squared, that means 3 squared times a squared. And 3 squared is 9. Here for the quotient property, 2 over 3 squared is the same thing as 2 squared over 3 squared, which is the same thing as 4 over 9. Or you could think of that as 2 over 3 times 2 over 3, which is 4 over 9. And this is the important one that we're going to be dealing with that may be a little bit less familiar. 2 to the negative 1 is the same thing as 1 over 2 to the positive 1, which is 1/2. In other words, we really can't do anything with the negative exponent. We have to put it in the opposite part of the fraction. Now we can think of this as 2 to the negative 1 over 1, and then just put it in the bottom of the fraction and leave a 1 in the top. There's always a factor of 1 in every kind of term. Okay, so here's some other examples that you might want to look at. Two to the 0, what does that equal? Well, anything except for 0. To the 0 power equals 1. So that's easy. 2 to the 1, well, that's just 2 to the first power, so that's just 1, 2. 2 squared is 2 times 2, which equals 4. 2 to the third, 2 times 2 times 2, which equals 8. So I think we're familiar with that. And then, as we said, 2 to the negative 1 is the same thing as 1 over 2 to the first power. 2 to the negative 2 is the same thing as 1 over 2 squared, which is the same thing as 1/4. And 2 to the negative 3 would be 1 over 2 cubed, or 1/8. 2 to the negative 3 is the same thing as 1 over 2 to the third, positive 3, which is 1/8. 2 times 2 times 2. But what if we've got a fraction? Well, let's say we have 1/3 to the negative 1. What's that going to be? Well, if we use this property up here of quotients, that's the same thing as 1 to the negative 1 over 3 to the negative 1. But then I could put this up in the top and this in the bottom, so that's going to be the same thing as 3 to the first over 1 to the first, which is just 3. So really what we do is we just kind of flip it and change it to positive. So if you saw something like this, 1 over 4 to the negative 1, that would just be over 4. That would be the same thing as 4 over 1, or just 4. So that's something you want to be aware of, because we'll be dealing with these as we're working with these exponential equations. If we have something like 3 over 2 squared, that's going to be the same thing as 3 squared over 2 squared, which is the same thing as 9 over 4. And you could always take this shortcut. I just want you to see how we use these properties from above, especially this one. Now, what if we had negative exponents? What if we had 2 over 3 to the negative 1? Well, we could just flip those again, so we would end up being, and I'll work it out, 2 to the negative 1 over 3 to the negative 1, which is the same thing as putting this up in the top, 3 to the first over 2 to the first, which is the same thing as 3 over 2. So basically, we're just kind of flipping it and changing the signs. Oops, sorry. Sometimes I keep writing without watching what I'm doing. So if you saw it as an example, something like this, 5 over 3 to the negative 1, that would be the same thing as 3 over 5, which is the 1 power. Just flip them. And if we saw something like 3 over 2 to the negative 2 power, then we could just flip those and say that's going to be 2 squared over 3 squared. In other words, 3 to the negative 2, and then put that in the bottom, and the 2 to the negative 2, put that in the top, and that's going to be the same thing as 4 over 9. And you can always pause these and think about these, make sure they all make sense. So those are some properties of exponents that we'll be using that will be handy for you to be aware of. Okay? And now we can kind of talk about the formal definition of an exponential function. I've got that written out over here with a couple examples. An exponential function is a function of the form y equals a times b to the x, where a is not equal to 0, b, which is my base, because it's to a power, is greater than 0, and it's not equal to 1. So here's some examples of some exponential equations. Y equals 2 to the x. In this case, the b is 2, that is the x power, and the a would be 1. 1 times 2 is just 2, so it would be 1. A would be 1. Here's another one. Y equals 3 times 2 to the x. Again, my base is 2, but now my a is 3. So this is also this form of an exponential function. And sometimes you can write it as y, sometimes we can write it as f of x. I did this one as f of x. F of x equals 2 times 3 to the x minus 1 plus 4. My base is 3, so my b is 3. The number in front is a, and a in this case is 2. And this is my exponent x minus 1, so we remember we have a horizontal shift of 1 to the right and a vertical shift of positive 4. So these are going to be horizontal and vertical shifts. Okay, so those are just some examples of exponential functions.